Hi everyone, welcome to this environmental DNA sampling tutorial where I'll be telling you all about these pieces of equipment that you'll need to collect your very own environmental DNA. You'll be given a 50 ml syringe, and this syringe is used to push the water that you've just collected through the filter. You'll be given a filter in this sterile packaging, and this filter is a Sterivex filter, and what this does is it captures the DNA in the water that you've just pushed through it. So it has an inlet and it has an outlet, and the DNA comes through here, gets caught in the filter, and out the other end comes purified water. So your Sterivex filter has a lovely locking mechanism which connects to your syringe. You can then push down on the syringe, and this forces water through the filter, and your DNA will be captured. So once you've pushed your water through your filter, you can then disconnect it, and you'll need to add on one of these caps. Now these caps are multi-purpose, so they're good for both the inlet and the outlet of the filter. So they come in these little sterile packages, and if we take one out, you'll see that it has two ends. So this end will fit into here, like that, but the cap will also fit onto the other side as well, so we just flip that around, and you can screw it on to the inlets like that. So the next part of the process, once you've captured your DNA in your filter, is to preserve that DNA. So you'll be given a 2 milliliter vial of preservative that will preserve that DNA. You then have a syringe that will be used to take up that preservative, and this will allow you to syringe that preservative into your Sterivex filter. So possibly the most important piece of equipment of the whole operation is your sampling bottle. So this is a sterile bottle that you'll use to collect the water from the river, and then you will take that water then to a safe location to filter. So you also have this storage tube for you to put your Sterivex filter in. You'll be given personal protective equipment in the form of some nitrile gloves, as well as some glasses or goggles. The main purpose of the nitrile gloves is that it prevents you from contaminating the sample with your own DNA, but also the DNA of the bacteria that live on your hands. And the goggles are there to make sure if you do get any preservative or the preservative splashes, it doesn't get into your eye and doesn't irritate your eye. So that's why we have these glasses. So we're now in the field here at the River Taff, and I'm going to be showing you how we use those materials that I've just gone through with you in the previous videos. So let me get them out of my backpack. We're now in a spot where we're not going to have contaminants falling from us, for example leaves from the trees. It's a nice clear spot. It's a safe space to work in, and we also want to try and avoid getting any dirt into our sampling equipment, as all of this can lead to contamination. So we want a contaminant-free and a safe environment, and we've got that here. We'll take out now our bag. Here we've got a little cover, but you can use a carrier bag, that's fine as well, just to make sure your kit isn't directly touching the ground. You can then take out your kit, place it on your carrier bag or sheet, and we're ready then to start unpacking what is in the bag. We've now got our kit all nicely laid out on our plastic surface. One thing that you also need to consider is if it's a windy day, you might have other contaminants blowing in, such as dust, all those leaves that I was talking about. So try and find a nice sheltered location. But other than that, we're ready to start sampling with our beaker. We have our sterile beaker. We'll take the top off, try and avoid spitting in it or getting any contamination within the beaker. So we can open the bottle away from us like this, place it in the water, avoiding any sediments that might be there, and simply dunking it in like that, trying to avoid any big particles. Take the water out as so, place your cap back on, and we now have our water sample. So we now have our water sample and we can begin doing the exciting bit, which is actually extracting the DNA from that sample. But before we can start doing that, we need to take this sample tube, which is where our filter is going to be placed to avoid contamination, and we need to label it with the sample name. So I'm going to do that now, and we do it now because later on this tube might get wet, and so it might be harder to write on with the felt tip. Okay, so we've now labelled the sample tube, which is ready for later. We can place that to the side. We need to start putting on our personal protective equipment. If you have glasses like me, you don't have to put on an extra pair of glasses, but if you don't have a set of glasses, make sure you put these on to avoid anything going in your eyes. And we need to apply our gloves as well to avoid contamination. So let me put these on. Go, glove one. And we want to try and avoid touching anything that isn't sterile with these gloves, so anything in the dirt, because they can get just as dirty as your hands can. So what we can do now is take the cap off of our sample. So we place the cap on just to avoid any dirt or debris from blowing in, but we can take that off now. We then take our syringe, our 50ml syringe, so we can take it out of its sterile packaging. We want to make sure we hold on to this packaging and that we take it home with us, so I'm just going to place that in there. We can now put the plunger in, pull the piston up, and have a look at how much we've got. So here we can see that I've gone over the 50ml mark, and so I just want to bring the plunger down so that horizontal black line hits the 50ml mark, and so we've adjusted that nicely, so we know now we have 50ml within that sample. We're now confident that we've got our 50ml worth of sample in our syringe, so we want to take our Sterovex filter next, which is over here. We take it out of the sterile packaging, but keep the sterile packaging to hand as it's a good place to keep the filter when you're not working with it. So we take that filter out. We take the inlet end of the filter and we put it into the syringe. And we then press down on the syringe for that water to be pushed through the filter. Now, we want to filter 500 mils worth of water ideally. That beaker will contain about a litre of water, but we want about 500 mils of water, so we have to do 10 syringes worth of water through the filter, but a minimum of 250 mil will also be fine. But ideally we want that half a litre. So we can then take the Sterovex filter off again, place it back in its sterile packaging, and we can get ready then to start doing the next 9. So there we go. There's our 10 50 ml syringes pushed through the filter. And what you'll find is it gets harder and harder to push down on that plunger as time goes on, because the filter is filling up with bits of sediment and other detritus in the water. So it could be that you might not get through your full 10 syringes of 50 ml, because some water will be more turbid and have more sediment than others, and so you may not be able to, because the pressure may be too much. But just try and get through as many as you can, hitting that 250 ml mark. We'll now remove the syringe. There'll be some residual water left in the Sterivex filter, so what we want to do is take in some air with your syringe, connect it once again to the filter, and we'll blow that air through the filter just to remove any of that residual water. We want to remove that water because it can dilute the preservative that we're going to be putting in just a second. We now have our dry filter with the eDNA within that, and we want to try and preserve it. And the first step of this is to cap it. So we take one of the caps from the sterile packaging, making sure to take all of the packaging home with us. We then take the cap and we put it on the outlet of the Sterivex filter. So that's the one with the thread. So you close that up nicely. We then take our preservative and put that down on somewhere flat, making sure not to spill it. That's quite important. So there's 2 ml of that preservative there. We take our smaller syringe out from its sterile packaging, and I'm just going to place the Sterivex filter back in the sterile packaging for one moment. You take your preservative, remove the cap, like so, and you take 1 ml of this preservative using the syringe. So this is a 1 ml syringe, so we fill it all the way up to the top. Like so. We'll put the cap back on the preservative. We then take the Sterivex filter again. We place the syringe in the inlet and you push down so that preservative then fills that Sterivex filter. So that will preserve your DNA to make sure that it's suitable for analysis. We take the syringe out, place it to the side. We take another one of the sterile caps, and this time we want to place the cap on the inlet. So like I described earlier, these caps work either way. So we turn the cap around, twist it onto the inlet end, and we now have a fully preserved filtered sample with our eDNA in it. And if you just invert it a little bit as well, just to make sure that preservative goes all over the filter, and take your the little vial that you had from earlier, that you labelled earlier, open it up, place your Sterivex filter in that vial and close it, and we now have a complete sample ready for analysis. Well done.